right. Thanks for listening while we took that short break here at Revolution Radio, freedomslips.com. And now we're going to get back to your host.
And we're back with another episode of Cosmic Catastrophe on Revolution.radio. I am your host, Diamond, from the Oppenheimer Ranch Project. And joining us today is my lovely partner and co-host, Leah Shaper.
Hello. Diamond, your microphone sounds really weird, like you're underwater or something.
Interesting. Is that any better?
No. It almost sounds like maybe you're on the wrong mic, like if you have a computer mic versus your auxiliary.
Okay.
I mean, I can understand what you're saying. It just sounds weird.
Yeah, I am on the HD webcam microphone.
That would be your problem.
How do I switch it?
You should be able to switch it in your audio and video settings in Skype. Sorry for the technical issue,
Audio,
folks.
I don't know where that is. Twin cam.
If you go to More, and then you've got a thing for audio and video settings.
Okay, we're there. Camera. Bear with us, ladies and gentlemen. Microphone.
You think you have the F fine?
And now I'm on the
There
F
we
part.
go.
Okay, ladies and
Much
gentlemen,
better.
sorry about that. We are back. The show today is going to consist of three amazing topics. I don't know if any of you heard, but a asteroid the size of Manhattan has just flown by Earth. It is a near-Earth asteroid that is called 887 Alinda, and we will discuss what the Alinda asteroids are. And if they are a threat to Earth. It's just an interesting topic. When we get into it, you'll see why. Also, in the headlines, a new ice core has just been extracted, and it goes back further in time than any other project by Epica. The Epica data that we use goes back about 800,000 years. And this core adds an additional 400,000 years, bringing back the ice data all the way 1.2 million. So it will be interesting to see what that data shows us. In the second half of the show, the most interesting topic, in my opinion, is who were the mound builders and what is going on in antiquity in North America. We're going to go over some interesting artifacts, including the Cincinnati tablet and other Adena artifacts. And we will discuss the relationship with what's happening in South America at the same time and maybe come to some conclusions.
Wow, were really frozen for me for quite a while.
Okay.
Pardon our technical difficulties today, folks.
Wow, that is crazy.
Mm-hmm.
All right, so the first topic, anything you want to add before we dive into it?
No.
All right, there she is, the near-Earth asteroid 887 Alinda. Is that a feminine name, do you think?
Well, I was sort of laughing to myself about it because my mother's name was Linda. So when you say Alinda, I'm like, oh, is it my mother flying by? It's Alinda. Now, yes, definitely a feminine name.
This enormous mountain-sized asteroid will be visible from Earth this weekend. It is so large that if you have a pair of binoculars and know where to look, you'll be able to see an asteroid. That's crazy. This asteroid has made its closest approach to our planet in decades. These asteroids have like a resonance, so they get close and far, and it's a repeating pattern, the Alindaroids here. This is one of the biggest ones of the Alinda asteroids. It measures 2.6 miles wide, which is 4.2 kilometers, which is roughly the width of Manhattan, the thin way. So it's not really the size of Manhattan, but the width of Manhattan.
Right.
So it made its closest approach to Earth in decades, swooping within 7.6 million miles of our planet, or about 32 times the average distance between the Earth and the Moon. So it actually wasn't that close.
Well, I find it kind of remarkable that you can see something that is only 2.6 miles wide when it is 7.6 million miles away. Not with the naked eye, but with a good pair of stargazing binoculars. Like, that's pretty remarkable.
Yeah, and it's kind of like seeing a Starlink satellite, which is 5 feet wide, because of it's at the right angle, the sun is hitting it, and then you can see it.
Well, then here's my question, right? Because this apparently is going to be traversing in the constellation of Gemini. But my question is the movement enough through a pair of binoculars to be able to pick it out? Like, is it going to appear static? Like, and then how do you pick it out if you don't know the stars very well?
Yeah, that's a good question.
Yeah.
Well, while this asteroid could trigger a mass extinction event if it were to hit Earth, it's not going to hit Earth. Now, on Sunday, tomorrow, January 12th, this object, which is 887 Alinda, is going to be at peak brightness at a magnitude of 9.4. It isn't bright enough to be seen with the naked eye, but it's bright enough to be visible through entry-level stargazing binoculars or a good backyard telescope. And, well, whatever that means, go get it. So some of these modern pieces of equipment, like modern telescopes, you just type in the object you're looking for. In this case, it would be 887 Alinda. And then the software takes you there. You don't have to do anything.
Wow, that's pretty cool. I didn't know that.
And then the nicer ones will track the object, so you don't even have to adjust anything.
Right. Fascinating.
So the Alinda asteroids are a dynamical group of asteroids with semi-major axis 2.5 astronomical units and an orbital eccentricity between 0.4 and 6.5. That might sound like a bunch of gobbledygook, but I'll tell you what's going on here. So there is the path of Alinda. If you rewatch tonight on Magnetic Reversal News at 8 p.m., you'll be able to see this visual. You can see the inner planets here and the sun, and then this would be Jupiter. So these objects move between Jupiter and the interplanets, the Alindas. And take a look at how close it comes to Earth's orbit there.
Yeah.
It never crosses the path of our orbit, which is why this is really not a worry for us.
Right.
But this is the closest it gets. It's pretty close. 36 distances from the Earth to the moon away.
32, I think. Yeah.
32. And you can see it has a slightly inclined orbit.
Yeah.
So why are these objects in our inner solar system, do you think?
Oh, I mean, I suspect that they're pieces of other planets, like from collisions, etc.
Yeah, and based on the trajectory of this baby, it could be left over from the Taurid meteor stream that ended the Ice Age.
Sure.
Yeah, it could be one of those leftover objects that got perturbed, a group of them, in a way that they're now stuck in this perpetual orbit. You froze up? Wow, we're just having so many technical difficulties. All righty then. Let me see if I can get Leah back here.
I'm here.
All right, go ahead.
Oh, that's funny. You looked frozen to me. So what I was saying was it would be nice if we could do some spectral analysis to determine the composition of these asteroids, and then that would give us a better idea of where they come from.
Yeah, here's a list of the members that we're following. There's quite a bit of them in that trajectory there, these Alinda objects. Some of them are in dangerous paths that cross Earth's orbit, and one of them just hit recently.
Just hit what?
Earth.
Oh.
Yeah. It says Alinda, the one we're talking about, 887, is a mid-size asteroid. Mid-size, the size of Manhattan. That's a mid-size. So they can get much bigger. And whose orbit approaches the orbit of Earth but does not cross it. It's not considered hazardous because computer simulations have not indicated any imminent likelihood of future collisions. Alinda orbits the sun every 1,420 days. So every 4 years, this flies by Earth. I've never heard of it. Have you?
No, that's quite fast, it seems. Given the size of the orbit?
Yeah, because it's making its way almost all the way out to Jupiter.
Yeah.
And because of the parabolic shape of the orbit, it probably gets whipped around the sun, and it's like an accelerator. So it gets really close enough to the sun that the gravity affects it, or the electromagnetism, however you want to put it.
Well, it's interesting because when you think about it, if this thing is orbiting every 4 years, then it would seem that there would be a risk in the relatively near future of a collision with Earth.
Yes.
Assuming that the orbit is not going to stay completely stable at all times.
I'm trying to find that data about the one that hit.
Yeah. Well, and so that leads me to think about at the end of this article, they talk about how, there's only like 5 asteroids that will make close approaches to Earth in the next century or something like that. But as you and I have discussed on this show before, that's not necessarily true, right? There is a problem where sometimes we don't even see near Earth objects until the last minute. So who knows what we're not seeing. I don't think that you can make a prediction like that just because we know sometimes these things surface and we're like, oh, look at that. Here's an asteroid coming by that's really close.
So here is an animation of just how fast Alinda is moving. That's pretty interesting.
Yeah, that's cool.
So every 3 turns around the sun there for the Earth is one. Yeah, and you can see it does speed up around the sun.
Yeah. Yeah.
So it takes a long, slow arc out here towards Jupiter, really slow right there. And then as it comes in, it really accelerates.
Yeah. Interesting. So the asteroid that actually hit was very small, I assume?
Yeah, absolutely. Most of these asteroids in this group are small.
How recently are we talking?
I think it was just like it was recently in the last few decades.
Huh.
But I can't. Another consequence of these and make up good study as well. Yes. So the 2019 MO impacted Earth June 2019.
That's funny. I mean, it's funny because you don't really hear about this stuff.
Yeah, well, we've actually located some asteroids that have hit Earth in recent years. It's only recently we have the technology to do that. I think it's around 10 now. We've seen 10 asteroids about to hit. The only problem is we locate them within like 10, 12 hours of impact.
Well, that's what I was just saying earlier, right? Like the prediction at the end of this article that suggests that there's only, 5 asteroids that will make close approaches in the next century. We don't know that because we do know that sometimes these things show up and we don't see them until the last minute. So these small asteroids hitting, I'm assuming that they landed in the ocean?
Or in an unpopulated area on land.
Right, right.
And also when they say hit, often none of these asteroids hit the Earth. They blow up above the
disintegrate
surface
in the atmosphere.
and then little pieces land on the ground.
Right, right. Which is why we have little meteorites everywhere, right? It's not that unusual.
No, if you were to take a trip to Antarctica, you could find meteorites easily. You just walk across the ice and they're laying on top. So what's interesting is you froze up again. The Alinda asteroids.
Maybe that's the question.
Yeah, you froze up again. Maybe I need to turn off.
Yeah, you froze up for me too, and I don't even know what our listeners on the radio are hearing, if they're hearing you or me.
So
or neither of us.
The Alinda asteroids is what you just said. These are the type of asteroids that are very difficult to see because of where they fly and their close proximity to the sun. When they're close to us, they're either next to the sun or behind the sun. And if you go out and look at the sun, you're not going to see anything. You're going to go blind.
Right. Right.
Okay. Anything else you want to talk about, Alinda?
Mm-mm.
Let's jump over to the ice core here. So for those that don't know, we've had high resolution data from ice cores since the 1980s, since the Epica program began. The first high resolution stuff came out in the late 80s, early 90s. And then
I'm so glad you pulled up this particular graph, by the way, but we'll get to that.
and then after decades of scientists, they have access to these ice cores. Each different group looks at it and pulls out a different data set from proxy data from either air bubbles or something trapped in the ice, like sodium, potassium, calcium, CH4, CO2, the amount of dust in the ice. And so all of these together give us a very high resolution of the climatic changes through time. And so we've got very high resolution of the last 800,000 years. And then past that, it starts to get fuzzy. We then have to start using things like lake deposits or continental shelf cores, which don't have as much data as ice. Ice is pristine. I mean, it has the atmosphere trapped in it from the moment the ice froze and everything. It has all the precursors of everything we need to unravel climate. So ice is great.
Yeah.
And it took a while to find 800,000 years of continuous ice. So what this is actually is different ice cores that overlap, and together they have the full picture.
Right.
So you take dozens of cores in different places, find markers, and then you can overlap the cores to create a continuous graph like this for the entire span.
Well, not only do you have to find the 800,000 years of ice, but in the case of the new Antarctic ice core data, it takes a while to drill all of that out. So for the new data set that covers 1.2 million years, it took 4 summers to drill all of that out.
Yeah, we're talking 2.8 kilometers of core.
Right, 2 miles.
And so they're only taking out sections of core at a time.
Right.
So they're extracting like 100-foot long sections or less. I don't know how big the sections are. And then they got to break those down because they have to be packaged in these containers that fit the core that can be stored at low temperatures so that they don't evaporate.
Right.
And so what they found is the oldest ice ever. They went all the way down to the bedrock, and then they dated the very last part of the ice there, and the date came in at 1.2 million years.
Amazing.
And this is going to be easy to corroborate or to prove because the upper sections of the ice core will match at around the 800,000 year mark based on the data, and then they can line them right up there. And then our new ice core data won't look like this. It will add another whole 400,000 years. So it's very interesting to look at this. This is the 800,000 year data, right? And it seems like around 420,000 years ago, the cycles happening back here are weaker than the most recent 100,000 year cycles.
That's interesting. I was looking at a different data set earlier today of the Vostok data. Was that what this is? And the graph that I was looking at did not really show this less extreme cycle prior to 400,000 years ago. Maybe I just didn't notice.
You can see it right here. Pretty obvious too.
Yeah.
This is an opposite. So this is the
Right.
recent 420, and then these are quite weak. They're not only quite weak, but they're less of a major signal. They're double peaked. Like this is a triple peak. There's a triple peak there. So there's something different going on, but very similar for the entire time frame.
Yeah. Well, I want to point something out in this article that brings up the news of this new set of ice core data. They have
I can't hear what you're saying. You froze up here on my end.
Shows that CO2 levels have never exceeded the levels seen since the Industrial Revolution began. And they say, today we are seeing carbon dioxide levels that are 50% above the highest levels we've had over the last 800,000 years. But this data shows that that is a total lie.
Yeah, right right here, CO2 is, why do you say that? So this is CO2 on the top. The highest you can find on the graph is 300, and we're now at 420. So that's 50% higher than the highest on the entire data set.
Am I not looking at this correctly?
CO2 parts per million, 300.
Right.
So
And
the
here we
modern
are
number here
at a
on the
level
right
below that,
excuse me?
according to this graph.
According to this graph, what?
According to this graph, at the 0 mark, our CO2 levels are lower than they were at whatever that is, 370,000 years ago.
This is incorrect. Today's number is 423 parts per million.
Okay. Fair enough.
Which is off of this chart, right? By 100.
Okay. Right.
So that's what they're doing.
Right.
But still,
nonetheless,
it means nothing. The CO2 was so low 700,000 years ago, everything almost died.
Right. Well, and also in the larger context of this graph, I mean, these regular peaks and the magnitude of them, CO2 being at 420 right now in the context of this really isn't that meaningful. I mean, they're trying to make it sound meaningful, and it's not like it's not NBC News making this claim. It's the scientists who are trying to suggest that this is alarming somehow. When we look at this in the grand scheme of things, and it's not. I mean, look at the range of CO2 on our Earth's history. You know?
Right, and you with a change of 100 parts per million, temperature is going up and down 10 degrees C.
Right.
That's it.
Right.
So there's really nothing catastrophic about any of the changes on Earth currently, especially the temperature change.
Right.
It's slowly rising. Any of these upward motions in temperature here, delta T, would be 100 times greater warming than we're experiencing right now.
Yes. Something else that I noticed, and it doesn't really show up in this graph, but the data set I was looking at shows a very clear signal at 100,000 year signal. However, the 100,000 year signal from the present going backwards starts at 130,000 years. So you get a peak at 130,000 years, roughly 230,000 years, then 330,000 years, which would sort of suggest that we're almost like 30,000 years late. Do you know what I'm saying?
30,000 years late for what? The last cycle was the Younger Dryas event. The 100,000 year peak had already happened. And that happened 13,000.
So that's the problem, is that the data set I'm looking at isn't accounting for the current data. But it looked like the peak, the last interval between peaks was like 130,000 years instead of 100,000 years. That's what it looked like.
Yeah, but from peak to peak, it varies. Some are tighter, like 100, some are 130. So it's highly variable. It's not a clock cycle, but there definitely is a nested hierarchy of something controlling this.
Yes.
At a small scale, at a grander scale, and at a very big scale.
Yes.
And it's all layered on top of each other. And this is some of the reason why we're not off planet already. Some of the reasons why our civilizations have been destroyed in the past, because of the intense variability of climate, natural variability. And the reality is we have no idea what is controlling this.
Yeah.
Because if what we think is true, the coming out of the last ice age and the Younger Dryas event, those are anomalous. That is not the driving factor.
Mm-hmm.
We would have gotten warm anyway.
Yes.
It was the anomalous cooling due to the catastrophe that makes it unique.
Right. But overall, it didn't change. It doesn't change the overall pattern.
No, because each of these Holocene or each of these interglacials in the last 500,000, they all ended the ice age. They just didn't end the ice age with a catastrophic comet breaking up the ice sheets.
Right.
It just got really warm and everything melted.
Yeah, right.
Perhaps. We don't know. I mean, this is all speculation.
Well, I mean, it's so interesting because, and we've talked about this a lot on this show, but I think it's worth repeating that one of the reasons why we don't regularly because of this cycle, right? We don't function as well during ice ages. Typically, there's a limit to what we can do. It there are times where we're more focused on our survival than we are on advancing our civilization. And so we kind of keep starting civilization over and over again, and we only get so far. But I also think this is interesting because it kind of reflects, we end up forgetting everything in the interim, and then we have to learn it all over again, which seems to be reflected as well in the Yuga cycle, where it seems like there's this period of enlightenment and then ignorance, and then we go back to enlightenment and back to ignorance again. And maybe that reflects our reincarnation cycles as well, because if we don't keep forgetting, then how are we going to learn anything new? But it is interesting that it does seem to impede our very long-term accumulated knowledge. Your mic is off.
It keeps getting erased.
Yeah.
Speaking of erasing history, let's dive into the next topic. For years, and only until recently, archaeologists worked under the assumption that all ancient life in North America, the natives, were hunter-gatherers, not that smart, not that industrious or productive. And this is all the while they knew that there were tens of thousands of mound structures, and unexplainable forms that were man-made across the country. And yet they still, knowing that for decades, were just like, these are dumb hunter-gatherers living in huts. And yet we've got all these pyramid structures. And as time progresses and better dating techniques come out, these mound complexes, the oldest ones, date back to the Younger Dryas. 11,500 is the base. And it appears as if each phase of cultural shift builds on the last. Take Serpent Mound, for instance. They said it was recent and it was done by the Fort Ancient, which only would make it a few hundred years old. But they did new stratigraphy and they found that the first construction of Serpent Mound, they think, was 3,000 years ago by the Adena. And then the Hopewell come and they rebuild on the same structure. They fix it. And then the next flourish of culture comes and then they fix it again. It's so, they call them different people throughout a 3,000 year span here. They name them Adena, they name them Hopewell, they name them Fort Ancient. As if there are different groups of humans migrating through here and finding the serpent and saying, oh, wow, we know what this is, and then fixing it. It's completely...
Without any explanation for what happened to the quote-unquote previous culture. There's no explanation for why they're not there anymore, and there's new people coming through.
Right. Well, we do know what happened to native groups, tribes in our area, and you can even ask the elders, is that they may be in a region for some time and then the climate changes and there comes a point where they decide to move.
Right.
And so they leave the area completely, go hundreds of miles south where it's better, and then they stay there for generations and generations.
Right.
And then at some point in the future, when things change, they may come back, or another local tribe may re-inhabit that area. But what we find at this time all over North America are thousands and thousands of mounds. Let me pull up just one map here. Okay, where are all the maps?
Well, while you're doing that too.
Go ahead.
Oh, okay. Go ahead.
Yeah, this is just one of the early maps of mounds and mound. It's either these red dots represent a single mound or a mound complex.
Right.
And this isn't even all of them. This is an early map. So if you replace the word mound with pyramid, these are pyramids in North America that lazy hunter-gatherers made.
Right. People with a similar culture, as evidenced by the mounds or pyramids, appearing across a huge span of geography. Yeah, these are just little simple hunter-gatherers. Okay.
The entire eastern half of North America, there's tens of thousands of these complexes, and they were all looted mostly or plowed under. The majority of them. That's how sad our history is. The lack of care about what was going on here is completely insane.
Wow. I know. It's interesting you see too how these groups of mounds follow the rivers. Well, it's not interesting, I mean it's common sense, but it makes it very clear that these people know what they're doing.
Some of them don't, though.
My.
Some of them
You are
follow
gone
nothing.
again.
Excuse me? You're frozen up. This is just the worst. This is the worst Skype conversation we've ever had.
I hope we don't have dead air here. I apologize, folks, for all of these technical problems today. It is unclear if this is our internet connection or a computer problem or Skype acting up. This is a particularly long delay this time.
I've got a lot of tabs open, but nothing is really taxing the system.
If you're able to hear me, then one of the things that's also very cool is that there is Wow, I just got knocked off completely.
Yes, you did.
That was crazy.
All right, so the mound culture, they attribute, let's see what the official narrative is. The mound culture, they put back beginning around 3500 BCE, which is 5,500 years before now. The problem with that is some of the mounds in Illinois, I believe, have been dated to 11,000 at the base.
I never realized actually that some of these went back that far.
Yeah, so the what would you call it? The mainstream accepted date is 5,500 years ago. They started making these mounds.
Right.
And they made thousands of mounds. And they're just not hills of dirt. They're very complex structures that were built up over a period of generations. And they were also burial structures. So let's say the first iteration of the mound is 5,500 years ago, and they put a chief in here, right?
Yeah.
And then the next group comes along and they improve it and they make it larger. And then the next group makes it a larger mound and a larger mound. And on top of these mounds, they were flat. These were ceremonial mounds that on the top, there were wooden structures, which look very similar to the Mayan pyramid constructions. Mm-hmm. Steep-sided with a little temple on top, very similar to these platform mounds.
You know, just to backtrack just a little bit on the dating, knowing that according to the article we were just looking at, that some of these mound building cultures were still around in the 16th century, this is an extremely prolonged culture. I mean, we're talking, what did we say, 11,000 years for the oldest one? I mean, that's extraordinary. So yeah, that's a crazy long time for any civilization.
Yeah, I'm a little lost here in the, there we go. So the mound culture was gone by the time the white man got here.
Yeah.
And what was left is the Native American tribes we know today, plus 50,000 others that were wiped off the face of the earth.
Right.
So by the time the white man got here in the 1500s, these large societies of mound builders were gone. And the collapse.
This sort of helps.
The collapse occurs the same time the collapse occurs everywhere worldwide. During the Dark Age, 1300 to 1500, everyone is missing. They're either dead or gone.
Yeah.
Yep.
I mean, this helps explain to why we regard these cultures as not much to write home about, because they were already gone for the most part by the time Westerners arrived. And so it becomes I think it becomes very easy to belittle the achievements of these people that way, because we didn't really see it. Although, there are the legends of, like, the city of gold in South America, etc., right? That may or may not be true, those kinds of things. But they're just treated as legend and folklore instead of potentially having at least a grain of truth to them.
Yeah, exactly. And here is a really good representation of what's going on. This is the GISP-2 ice core from Greenland. These mound cultures began at the Holocene warming. You know what also begins here in South America? The Maya culture. 11,000 years, the Mayans and the mound builders are all over North and South America. And as time progresses, they get more and more advanced culturally and societally, and build more and more advanced structures. The peak of mound building on this graph is kind of like leading all the way up to the Minoan warm. But it begins at the Holocene optimum. So it's pretty warm the entire time. It's easy to do everything. There are some cold periods as we head on down to the medieval warm here, but all of these cultures get decimated here at the Little Ice Age. They're all missing beginning at the very beginning of the Little Ice Age here. And I don't think they're missing. I think their numbers dwindled so low, they had to leave the cities. They couldn't do what they were doing before. And then they had to go back to their sedentary, small, humble cliques of hunter-gatherers again. This is a cold period. We've discussed this with hominids on a grander scale. And so the same thing's happening here to all civilizations, all empires worldwide. All of the empires in China and Japan fail at this time. The European Dark Age, we don't know what's happening there. That's what famine and pestilence, and everyone dies in civilized society. It's happening worldwide. It's a worldwide phenomenon.
Yeah.
Yeah.
Yes. Yeah. It's definitely not a coincidence that we call it a dark age, because it was a dark age not only for the times, but because we don't know what the heck was going on exactly.
We do know it was cold. There were no sunspots. And all these people went missing.
Yeah.
Just as a side note, there is an amazing duo back in the 1800s that cataloged many of these mounds and many of these structures. And they created a volume called Ancient Monuments of the Mississippi Valley. You can get a copy of it. And the two responsible are Squire and Davis.
Right.
Now, we have a modern book that uses Squire and Davis. Do you have that?
I do. This is a book by Greg Little that was published in 2016, I believe. Copyrighted 2016. And it's basically an encyclopedia of all of the mounds and earthworks that we know of.
Yeah,
which
it's
is
pretty
fascinating.
fantastic. And he's very...
Thank you to Ransom for this, by the way.
Yeah, what's his name again? Greg Little?
Gregory Little. Gregory L. Little. And this is called the Illustrated Encyclopedia of Native American Indian Mounds and Earthworks.
Yeah, you can find Greg Little on X, and he's very accessible. You can just message him if you want and ask him any questions about this. So Squire and Davis are responsible for these amazing maps with all these dots for the most part.
Yeah.
But there was no such thing as anthropology or archaeology in 1840 when they're doing this. So these guys are like explorers, engineers, and surveyors. So they have the ability to survey these sites in great detail and catalog them for the future, because they knew that they were very unique. They thought, this is a long lost something. We don't know what it is. And the whole idea that there's no science of archaeology at this time is it's crazy. It's 150 years ago.
It's hard to wrap your head around because for that to not exist, you would have to assume that people were generally not interested in the people that came before them, which I find strange. Like that seems like a natural curiosity to me, but perhaps it's not.
Yeah, well,
Well, maybe it's really only of interest at a certain point in civilization, a certain level of comfort and stability, right? In the sense that maybe at other times you're just more interested in achieving your own stability. I don't know. It's strange to me. I don't get it. Well, and then the other part of this is the lack of any kind of reverence or respect for these mounds on the part of many people, right? So many of these mounds have just been bulldozed and destroyed, to make way for something else.
It was a hobby at
we
the
were
turn of the
talking about
century. Mound digging was a weekend hobby. People went out, had picnics, and destroyed the mounds and found stuff.
Right. Right. Well, you and I were talking about the Cincinnati tablet last night, and that was found in a mound that was literally being bulldozed to make way for, I can't remember what it is now, like a Home Depot or something.
The Cincinnati tablet is one of the best representations of these mound builders' art and sophistication. There are a number of these tablets which are referred to often as Adena tablets, and they are about the size of a postcard. They measure like 3.5 by 5, and they're made from all different materials. This particular one is sandstone, and a lot of the more intricate ones are done in the sandstone. But they've been found made from other materials too. And some of the tablets are, shall we say, crude as compared to this.
Or are they crude or eroded?
Could be both.
Yeah.
But some creepy stuff to think about. This Adena culture here, and we'll dive into it, is like the middle or the peak of the mound building empire. There's probably millions of cities across North America operating at very high capacity, huge trade networks. The Adena here were trading products all the way down through the Gulf of Mexico up into Canada. And so just huge groups of, this is high civilization in North America before it all crumbled. And the Adena are also responsible for some of the oldest archaeoastronomy we know of in North America. And here's what's funny. They studied Serpent Mound, which we have up on the screen here, for years, decades. They had the wrong date. They were off by thousands of years. And they had no idea how many archaeoastronomical alignments that this mound represents. It was only in the last decade or so that people started looking into it. And this is a 3,000-year-old culture. And maybe it is now assumed that just maybe the Adena found the remnants of this structure and fixed it, and it may be even older. And the reason is because the summer solstice sunset is off a little by 3 sun widths. So the sun actually is off from this marker. But if you roll back the time, 11,000 BC, the sun would rise exactly at the solstice, at this marker.
Right.
So this may be 11,000 years old, the same age as similar archaeoastronomical things being built worldwide, like Göbekli Tepe, those circles.
Yeah.
And so this may all correspond to the end of the Younger Dryas after the catastrophe. We're trying to preserve all the ancient knowledge because humanity has been wiped out. And that's what this represents. And this is why this culture stayed there and took care of it for thousands of years.
Right.
So we've got the true north alignment, summer solstice sunrise, equinox sunrise, and the winter solstice sunrise, all represented here in this earthwork.
Well, the nice thing about this explanation too for its existence and talking about, marking the direction of solstices, equinoxes, etc., is that it helps explain because the temptation is to think that this serpent mound sort of only serves a purpose when looking at it from above, but that is not the case if it's actually marking astronomical events. Right? Obviously, if you're on the ground, this telling you where the solstice or the equinox is makes a lot more sense in that regard. It's not a glyph in that respect.
Yeah, and what's even weirder is that archaeologists explain these alignments as the need for the native people to know when to plant their seeds, and I find that ludicrous.
No, that's retarded.
Yeah,
it's like that's not
this is
hard
far
to
beyond
read.
that.
Yes,
this is far beyond that.
It's so insulting, right? That it only comes down to essentially your day-to-day needs, right? As if these people were incapable of thinking of anything larger than themselves. Once again, we're insulting the intelligence of our ancestors in order to make ourselves feel good and smart and intelligent and, better than we were in the past.
Yeah, so these hunter-gatherers are so dumb, they've got to make this giant earthwork to figure out when to plant their beans. I mean, it was a deeper cosmological knowledge that they were well aware of, and it had much deeper meaning that we will never know. And of course, you froze up again.
I'm back. This is so annoying.
So some of these mound structures, they're all so unique, depending on where you are geographically. One of the most impressive and unexplained is a place called Poverty Point. It's in northeastern Louisiana, and it consists of what appears to be a stadium-like setting where everyone is looking towards the river, or where maybe a show could be happening down here on the floor. It's an UNESCO World Site covering over 400 acres. It's just a crazy, amazing place, and it has a pyramid, I believe the largest mound structure anywhere in the world, or something ridiculous like that. That would take the equivalent of 28,000 commercial dump trucks full of soil to create this pyramid. 28,000 commercial dump trucks. So how many people? And they think that they were using woven baskets to move the soil. How many people would it take to move 28,000 commercial dump trucks?
Right. Right.
Researchers have learned that Mound A was constructed quickly, probably over a period of less than 3 months. So these are massive constructions, rapidly put up, with 28,000 dump trucks worth of soil. How many people did that?
Right. And where are they bringing the soil from? Like, is there evidence of it being excavated from somewhere nearby or not?
Typically, there is, but they're by a river here, so they can easily just get this sediment from the riverbank. So that's one way to think about it.
Nonetheless, it's still an amazing feat.
And this structure dates back 3,250 years ago.
Yeah.
Here you can see on LiDAR. So pretty fascinating there.
Yeah.
So this culture that's around in North America 3,000 years ago, I believe is directly linked to the Mayans. And we just haven't made the connection. A good example is the Adena pipe, which is dated around 2,300 years ago. It's an enigma. And if you look at the carving of the toes, bottom left here, and the skirt, and the earplugs, and you look up the Mayan corn god, he has the same types of toes, the same earplugs, and the same weird blocky headdress as the Adena pipe.
Yeah.
There's no way you can't connect these two.
Yeah.
This is another Mayan god. And if you look at the center plate here, this looks awfully close to an Adena tablet right here hanging off of his necklace.
Right. Right. Yeah, I was going to say that all of the imagery on the Adena tablets that I've seen thus far all looks stylistically like Mayan.
And why can't it be? The Mayan civilization is right here, occupying most of the Yucatan Peninsula all the way south to the Pacific, which if they just move up the coast here, they're in Texas, and then they're at the mouth of all these rivers where if you paddle up, you can make more pyramids, which is where all the mound builders are making mounds.
Right.
Either that or they're all, like we said, the mound building culture has trade routes that go all the way to the tip of Florida. So they probably have trade routes that go to the Yucatan Peninsula as well.
Right. Right. Well, and then you think, when you think about it,
the peak period for the mound builders is the same as the peak period of the Mayans, 3,000 years ago.
Right. And the migration from the Yucatan, let's say, up to the southeast U.S. is really not that difficult, right? Because you're along the Gulf Coast the entire time. There's going to be plenty to eat. You know, it's not going to be a particularly stressful travel. And, you know, it may not even be a migration. This may be a very slow expansion, really, you know?
Right, where you still have groups of people that even though there's high civilization here and like Tikal and all these pyramid complexes, there are so many people here during the Mayan epoch. It's well documented there were overpopulation issues. Break-off groups went to establish their own regions. So you just got groups moving up the coast here. Look at all the fresh water coming off of North America. You just go from river to river, and it's easy. And then you encounter other groups, share knowledge. At this time, 3,000, 4,000 years ago, we had advanced archaeoastronomy, advanced engineering knowledge, and we're building pyramids all over the world. This also corresponds to what they claim is the time they're building pyramids in Egypt. So it's a worldwide phenomenon. And you froze up. And so here's a great example of a Mayan pyramid with a temple on top, similar to the mound builders. Nice. There you go. You're back.
So irritating.
And here's another Mayan god, which looks much like the Adena pipe. I mean, this is in a site in Ohio.
Right. I mean, that's crazy to think about. I mean, just put this image together with natives living in Ohio and tell me that these aren't Mayan people that expanded from their original location, right?
Yeah, I think they're all over North and South America at this point.
Right, right. On the Adena tablets, it's kind of funny to see all of the different ways that people have tried to interpret what these were used for. To me, it seems fairly obvious that this is some method of transmitting information and that you could use this as a stamp, right? So it seems like it provides multiple purposes in the sense that, you know, you can take this thing and you can, you know, because some of these were found with red ochre on them, right? You could take this and stamp fabric or leather or whatever. But then you could also carry this with you if this is some important piece of information.
Yeah, there's a lot going on. They seem to be broken up into 4 quadrants, each one depicting its own story. And just fascinating because just about 1,000 years earlier than when these are being made is when all the clay tablets in Mesopotamia are being made.
Right, right.
There's a lot we don't know.
Find us tonight on Magnetic Reversal News at 8 p.m. Mountain Time on YouTube.
Listening to Revolution Radio.